Hello, this is Lucas from Wilger Industries. I just want to walk you through Tip Wizard and how to use it to really pick your best tip for what you're trying to do. Simply enough, we'll start off by selecting your application unit by preference. We'll use US gallons an acre. We'll start off with a rate controlled sprayer system. So again, when you're speeding up and slowing down, your pressure is fluctuating to be able to keep your rate consistent. And then we'll select search for spray tips. You will notice there's a few other options for both the pulse width modulation system or select a specific tip lookup or favorites. But for this example, we'll use for search for tips and a rate controlled sprayer. We'll hit continue. Simply enough, plug in your application rate. So we can start off with an application of maybe 10 gallons an acre, say traveling 15 mile an hour on a fairly standard 20-inch spacing. And chances are, if you're using a self-propelled sprayer where you're able to maintain your height a little bit lower or change your height, you might be using 110-degree spray tips. So far, so good. Usually those are things that you know about your sprayer or your application. Often though, with this last option here, where it says target droplet size, that's usually where people get lost a little bit. So based on the chemical you're applying, we allow you to plug in a target droplet size based on micron size, really to hone in on what would work best for your application. So in the chemical label, it'll say something like spray with an ASABE coarse spray, or depending on your country, it might be a little different, but nonetheless, it'll give you that spray quality characteristic. So let's say, given this application example, it would be a glyphosate application, pre-plant or pre-emergent burn-off application. If we looked in the chemical label for glyphosate, it recommend a coarse spray. So coarse, then we give you an estimate, a droplet size range. Again, the droplet size range is more of an estimate for this, as even if your droplet size is outside of that range, it still might necessarily be a coarse spray based on the standards set by the ASABE. But nonetheless, most applicators, in Western Canada here at the very least, where there's less drift sensitivity and more open fields, usually 400 microns is a reasonable level. If you are in conditions that are more drift sensitive, then typically what you'd end up doing, you'd actually change that droplet size, target a coarser spray. So might be in the realm of 450 microns, just to shift that whole droplet spectrum by around that 50 microns, just to minimize some more drift for those sensitive conditions. For this condition, or for this situation, 400 microns should be sufficient. I'll click search. So Tip Wizard, it'll show you a few different options as far as tips and tip sizes. Not necessarily meaning the first tip is the best option. It's just ranking it based on size. So with that, there's also a few buttons up here. So this is just a recommendation for best matches, and then there's a legend there too. So in the chart that will pop up once we select some result to look at, it'll have a whole plethora of information as far as what's included in the chart, what it means, and what you can kind of use it for as a tip selection criteria. So we'll open the MR11004 as our first option. So simply enough, from left to right, you have your speed. So we've set our speed at 15 mile an hour nominal as our average speed. With this tip, we'd be spraying at around 64 psi to put on our rate at that 10 gallons an acre that we put down. So that's the effective sizing of the spray tip. So for some applicators, they may find that 60 psi is a little bit too high, that they'd like to run for their average spraying speed. If you are in that same consideration, what you'd end up doing is go to the next size spray tip. So whereas you see 04 and color-coded a red tip, that's a physical flow standard. So that's an ISO standard set by the flow rate. So even though you see the MR series here and then the DR11004, which is also a red tip, the pressure that they'd be operating at would be the same. So if you were going to look at a larger spray tip to get that pressure lower, you might be looking at something like the MR11005. We're going to operate under the assumption that 60 psi is not too high. Again, 15 might be more close to your max speed. But we might look like at something like this. So this is the DR11004. So it's a little bit coarser than that MR series that showed up there. if we looked at that just quickly, you'd notice that at 64 psi, the droplet size, or that VMD, is quite shy from where we were targeting. So we were targeting 400 microns. So TipWizard shows that just as an alternative, more so if the case that if you're able to slow down, you can still use that tip or whatnot for that ideal application. So we'll focus on this DR11004. So at 15 mile an hour, we have plenty of room to slow down without losing our pressure. You're going to be able to keep your pressure up a lot better. As far as the droplet characteristics and such, right around that 64 psi is right where the droplet size, or that VMD, so that volumetric median diameter, is just around 400 microns. With that, we have the classification right beside it. So there's a C, or blue, which is coarse. So again, that's just visualizing that standard and color code there. So the next column here gives the percent less than 141 microns. If you did refer to it in the legend right at the very top of the screen there, it will read as such. So you can consider that as your driftable fines, or the percent of your total flow which is likely to drift. Effectively, that small of a droplet size, it's too small to be very effective. So consider, or to visualize it, as soon as the spray leaves the spray tip, that droplet size, or the droplets that size, they're more than likely to be traveling 3 to 6 inches outside of the spray tip, and then dramatically slowing down to the point where there's just gravity and spur speed and wind speed taking it down to target. Which, as far as control goes, or trying to maintain control over that stuff, is pretty much impossible, without extra systems or alternative measures there. So in our case, at 64 psi with this DR11004, we can expect, in ideal conditions, around 6% of our volume would be pretty well uncontrollable. So for the tip selection process, what we might do is actually write that off. Consider it this way: for a decision, that stuff is a spray that is risky and can't easily be controlled. So we'll consider that. Usually in reasonable conditions or reasonable environment, within 10% drift for something like glyphosate is pretty reasonable. Again, we're within 6%, somewhere around there. Also, keep in mind, we do have that ability to slow down to reduce our drift further. So even if you slow down to 11 mile an hour, your pressure is going to be dropping with your auto rate system to around that 35 psi, to which we've dropped our drift, or driftable fines, down to roughly that 4%, which again seems like only 2%, but that's pretty much a third of your drift of what you're getting in those higher speeds. So the next column is the percent less than 600 microns. So if we looked at the legend there again, that's kind of what we'd call the percent of useful droplets for most applications. Most applications require some level of coverage. Some need more coverage than others. Glyphosate being a systemic herbicide, so again, when you just need that contact on the plant somewhere to try to kill or control the weed, you don't necessarily need as high levels of coverage. So if we consider that last column as our relative coverage, you can assume 84% of our chemical, or our chemical volume, is pretty well small enough to give us reasonable coverage. So if I were to use a rule of thumb for a systemic application like glyphosate, typically you'd want to try to keep that number above 80% to give yourself enough coverage, enough small droplets to give you that level of coverage that you need. On that same note as that rule of thumb I kind of mentioned for that percent driftable fines, you might use something like within 10% in that. So this tip selection, as it happens, at 6% drift, we're sufficient on our drift control for our conditions and chemical. But also too, on the coverage side of things, we're going to be good. We're going to be in a good place for coverage, being able to both manage drift and still rely on our coverage. TipWizard, the nice thing about it is that when you slow down, it gives you that visualization, the drift control and the coverage. So if we slow down to that 11 mile an hour, as I mentioned, let's say if we're doing our outer boundaries or more drift sensitive areas, you can slow down to 11 mile an hour. Our pressure drops because our auto rate controller needs to keep our rate constant. Our drift goes down, our driftable fines goes down to 4%, and our coverage goes down to 73%, that relative factor there. So it gives you a pretty reasonable shift, or that an idea of that balancing act between drift and coverages. Both are required, but again, it's just a means to understand that at 64 psi, 84% of your spray is nice and small. If you're slowing down, you're going to be giving up around 11% of your small droplets that would be making up your coverage, to reduce your drift by that 2%. Again, these are all factors and figures based on water and tested conditions in lab settings. It's not going to be realistic to be able to expect exactly that in the field, again with active chemicals and everything else. But it gives you an excellent decision-making tool to be able to really pick what's best for you. Since your farm is different than, well, probably the next guy, and you know your farm better than anybody else. So this might be what I might look at it as a suitable option for a spray tip for that 10-gallon application of a burn-off or a pre-burn glyphosate. To give you a better idea, rather than just showing you one of the better for that application rate, to give you a tool to compare one tip to another, what we'll do is use that relative coverage factor. So let's say at 64 psi, 84% of our chem is nice and small. From that, we'll subtract our drift, or driftable fines, so that's 6%. So what it end up doing is 84 less 6, so we have 78% of our total chem is pretty well effective for what we want to do with it. So again, if you're comparing to a different tip, it can make the decision process a whole lot easier, to put it that way. If we compared it to that MR11004, if we clicked it open and we saw our relative level of drift is 10%, our relative level of coverage is 94%, so we'll say 94 less 10%, so we're at 84% effective spray. So there is more effective spray with this, but that drift level, or that driftable fines level, is quite high. So typically that would be the decision-making tiebreaker, if you will. So for that one, that might disqualify that tip from being used for you, for your application. Still, it's within chemical label, but again, it's more to tailor the tip selection to your conditions too. So yes, this tip might be satisfactory for some, but those that need more drift reduction, the DR11004 might be that option. To give you another quick comparison, if we compare that MR11005 at 78% small droplet and subtract 5% drift, we're down to 73% effective spray overall. So there is that nominal gain by using that DR11004 at a higher pressure, which will give us more effective spray, but also to minimize the drift and give us more of a pressure window or speed window to reduce our drift in those conditions that need it. So yeah, that's Tip Wizard. This is how you would see it on the app itself, which is downloadable at pretty much any device app store, such as Apple, iTunes, and Google Play and such. If you are using Tip Wizard on the wilger.net website, there is another icon right beside these stars. So these stars, they're intended to be used as a favorites tool. So if you want to remember that for later. But on the website version, there's a little print icon. So if you hit that print icon, it's an excellent tool to have in the cab, as it'll print out a specify chart for specifically your application, your travel speed, your application rate, only the tip you're looking at or that you have on the sprayer already, just to give you that resource or reference while you're in the cab already. So you have an idea where your driftable levels might be, and how to maybe adjust that while you're actually spraying in the field. So, all right, thanks much.